Hi, good morning everybody, and welcome to EPA's Computational Toxicology Community Practice. My name is Cameron Clark. I'm a student contractor here in NCCT. Today we're going to be hearing from Tony Williams, a computational chemist in EPA's National Center for Computational Toxicology. And he's going to be presenting on the CompTox chemistry dashboard v2.6, delivering improved access to data and real-time predictions. And before we get started, I'm already hearing a little bit of feedback. If you're participating on the webinar, make sure that you select the participate in audio via phone line option and or mute your line so we don't get any feedback. If y'all have any issues with audio, please speak up or type something into the chat box and let us know. But with that, I will go ahead and let Tony take over.
Is it safe to assume everyone can see this?
Yeah? Yes, everybody should be able to see the slides now, so if that is not the case, let us know.
Okay. So I get to put my name on the slide deck, this time as the only person involved, but every time I give a talk, I'm literally switching out the list of people who are contributing to it, because the dashboard serves many groups at this point in various ways, and if I was to put on here everybody who's contributed to what I'm about to show you, I would have 3 or 4 slides dedicated to all the contributors. I'll do that in the acknowledgements. What I want to do is give you a very basic intro to the dashboard, and I mean literally what we've been doing to get to this point where I'm going to give you today's update. I'm going to hope for some familiarity with what we've been doing. I'm going to tell you about our latest release and how you can get to the details of what's new in this release. I'll point you to new data and functionality as we go through. I will tell you how we're moving from data to real-time predictions, and I'm going to tell you about some of the work in progress that we already have prototyped. I'm not going to read this out to you. I'm going to let you browse it because you're not sitting in the room with me. But the dashboard has been brought up pretty much to integrate various forms of data that we have been working with inside NCCT for over a decade. We've also started to integrate public websites and services that are available, bringing those together. We've been aggregating data from multiple sources, public databases, directly from the literature, and pulling together a whole set of functionality to layer on top of these data sets to serve it up as an integration hub. And with this latest release, we've then plugged in some of the algorithms that we use to predict the properties that we surface through the dashboard and are making them available for real-time prediction. What this means is that you don't have to have, the chemicals that you're interested in don't have to be in our dashboard in order for you to generate predictions in real time. We're early in that development, but I think it's been a good first release. I'm not going to walk you through how it's built. That is a presentation of its own. That's at least a couple of hours. But if you want to know how it was pulled together, we have now published what is pretty much the definitive article on how we got to this place. It's a Journal of Cheminformatics article. If you just do a search, JChemInf and the CompTox dashboard, you'll find it. Also, these slides will be circulated, so all of the DOIs will be available for you. But that's the place to go read how we built it. If you come to the home page now, you will see there is a news item right at the front that we did a dashboard release on March the 7th. We were willing to take the risk of showing this at the SOT and ACS. We always put ourselves right on the line of when will we do the next release. And it rolled out literally a few days before SOT, and everybody can see the latest and greatest capabilities. On this announcement, you will see right here in the announcement, a list of release notes is available. If you want to know everything that was done, you can click and you will get, as I recall, a 5-page PDF that lists all the fixes that we did, because every software release, every data release has issues, so we will list all of that, but you'll also see the 2.5 pages of new functionality in summary, so it will give you a little bit of a hint at what we've delivered. In terms of data, we've added about 3,000 chemicals since last release. We have extracted phys-chem data for chemicals of interest from the literature and added those in, so those are visible to you. We have made test predictions, and by test I mean toxicity estimation software tool. These are algorithms built by our colleague in NERML in Cincinnati, Todd Martin. So we used his prediction algorithms to predict across all structures that could be handled by the algorithms across the entire database. We continue to add more human and eco hazard data and curating those data. That's always ongoing. We're always adding data, we're always curating data. So that's been expanded on, and we've also added production volume data. Let's look at the detailed chemical pages. The look and feel has not changed significantly, except there are some new tabs at the bottom for a particular chemical, as well as right here alongside the chemical structure. You're going to see things like linked substances, presence in lists. One of the things we do is we continue to register lists of interest to the agency, to NCCT, to scientists that we work with. These can be sets of chemicals numbering from the tens to the thousands. We keep these segregated as lists in the underpinning database so that you can actually see them as a particular set of chemicals. These are segregated into federal, US state, international, and other. And you can click on any one of these blocks. For example, NIOSH International Chemical Safety Cards. You click on that block, and it opens up that subset list and displays all chemicals that are a part of that list. This just goes to show you what we're layering into the system in terms of lists of interest to us with the work that we do. There are alternative ways to access the lists, and that is at the top. Right next to batch search, we have a lists page. I will focus more on that a little later. That has been available for a while. We've also laid on the record information in terms of quality of data. We have 6 levels of quality data in the underpinning database. Level 6 is not displayed to the public. It is there for us to curate the data and move it up into the other 5 levels. And you can see for this particular chemical of interest, it is expert curated, highest confidence. That means that somebody has looked at the chemical structure, the name, the CAS number, a number of the synonyms, and made sure that it is validated to the highest level. I go through this in some detail in the publication, the Journal of Cheminformatics publication, where we explain how we are doing some of this curation work. There is a new tab. It is the first tab that is shown for the majority of chemicals, called the Executive Summary. And this is trying to summarize what is available for this chemical across the entire dashboard. It is pulling from the PhysChem and Environmental Fate and Transport tabs. It is pulling from the hazard tabs. It is pulling from the bioassays, ToxCast, Tox21 data. It pulls it all into a summary page that shows you what is available for this particular chemical. So it tells you you have PPRTV values available. You can click on this external link and it will take you into the dashboard, into the literature tab, into the PPRTV sub-tab, and show you the actual document where there is data available. The reference dose, for example, will link directly into the hazard tab and sub-tab. So this is a summary that is displayed. It also includes showing some of the PhysChem data that is available, log P, log BCF, and vapor pressure. Also, we have the point of departure plots for oral and inhalation POD when available. We have a summary of EDSP and ToxCast active calls, plus there is also the bioassay widget showing all of the data in ToxCast. I just happen to have not shown it here. I will show it a little later. So that's the executive summary. That's brand new. We have continued to expand the data available through the chemical properties tab, and so there you will see new data shown here. When we don't have experimental data, I believe everybody is aware at this point that we do predict it. We use various prediction algorithms to do this. The one that we recently published on, this was about a month ago, this went online. This explains how we build our opera models. This is also a Journal of Cheminformatics article, open access. You can go download this. Also underneath this is links to the GitHub code for the prediction algorithms, the training sets, the test sets, and all of the QSAR model report format data. We have redesigned the display to make it a little more simple to consume, as well as make it a little more amenable to mobile devices such as tablets. The data shown is not much different. It's just we've redesigned it, but it shows you the nearest neighbors from the training set for this particular chemical. You can see this green here saying inside applicability domain. If it was outside, it would be in red. It highlights it. It's a visual cue to have you pay attention to what we believe the quality of the prediction is for this model. It gives you the local applicability domain index and confidence level, and this is a distribution of the data, training and test data, with a link to the QMRF report for every opera model that we have available. The number of opera models continues to grow, and we have others in development right now, including a PKA model that we reported on last week at the ACS meeting. The test models, going back to our colleague Todd Martin in NERML, this is his toxicity estimation software tool. It's been around for a number of years. I will go into detail about how we have pulled the algorithms out to make them available for real-time calculation. Using test and the reworked algorithms, we predicted all of the structures inside the underlying database, DSS Tox, were pushed through, and when they could be handled, we will have generated the predictions. It includes detailed calculation reports. So in the chemical properties and environmental fate and transport, you will see a link to the test report, and it shows you the detail of how the calculation was done. This is a different layout than we have for the OPERA model reports, but our intention is over the next few months is to work with Todd and figure out how to bring them into one single format that is amenable for making sure that everything looks the same across the dashboard. We have consistency and homogeneity. Hazard tab, which was previously called ToxVal, we've renamed it. We've aggregated the data. We've been curating the data, cleaning up and adding more data. We've got a human eco split that you can see right at the top here. We've had to rebuild this table view for it to be able to show more detail. We have links to the source of the data that is displayed in each one of the rows. You can, of course, download the data into Excel or TSV files. And this particular link on the left-hand side takes you to more explicit detail about a particular value and source that is displayed in the hazard table. We've been working on the bioassays, so we still integrate the ToxGas data, of course, and PubChem. We also include their widget. We have redesigned this widget for display so that when you see the graphic that is displayed here, you can download it directly to the desktop as a PNG file. You can copy all of the assay details, and this is the assay details displayed is at a data point level. So you click on any of these data points and it shows you the assay details. Anywhere you see a visual cue such as this informational icon here, that means if you click you will get more detail, including links to peer-reviewed publication and a description about what a particular part of the dashboard is showing you. So anytime you see these eyes or question marks, please click and you'll get to understand a little more about the dashboard. Working with colleague Stacy Flood, she's put a lot of work into detailing out the assays. So when you see assay description with a number here and a hyperlink, it will take you to a detailed description as a PDF file of this particular assay. This is many pages in length. It is a level that should be fully acceptable to anybody wanting to understand the assays that we've used for our high throughput screening work. We only have it for a limited number of assays. My recollection is around 50. There will be more data coming online in the next couple of months. Getting all to this level is a lot of work, a couple of years' work probably. Under the exposure tab, we have expanded on product and use categories. We have new data here. There is a publication that has gone in and accepted for Nature Scientific Data that will be published shortly. This work is done with our colleagues in NERL, so Kristen Isaacs, Kathy Dionisio, Catherine Phillips. We also have the chemical weight fraction data. This continues to expand as they source more information and extract it from things like SDS sheets. And what we've added now is production volume data that came out of the CDR database that was added recently. That is not available for all chemicals we have in the dashboard. There is a new tab called Related Substances. It is next to similar molecules, similar compounds. So the Related Substances is going to link you to those chemicals that are related by things such as metabolic transformation, where the chemical is one of the components in that substance. In this case, this is chlorothalonil, and these particular set of chemicals are transformation products. Metabolites that have been identified by mass spec, reported in a publication. We are doing a lot of work internally now on things like metabolic competence of some of our high throughput assays. We're working with our colleagues in mass spectrometry where we're interested increasingly in transformation products and metabolites. So we've built this capability into the dashboard also. Under the synonyms, you will see chemical names, CAS numbers, active, deleted, alternate CAS numbers that are shown. There are different levels. There are the valid synonyms, good and other. You can, of course, copy all of these. This has been there since day one of the dashboard coming online. But to point to how these are being used, they're being used specifically to allow for linkage into external sites. So sometimes we are using those synonyms and CAS numbers to perform the linkages. We're also using these to feed into our searches in Google Scholar and in the abstract sifter. So if you want to search Google Scholar for a particular chemical of interest, click on this sub-tab, and it will push the CAS number and the name over to Google Scholar. And you can add a query term such as hazard, exposure, toxicity, and it will search Google Scholar and surface a list of articles. Then it's up to you to wade through them. Our colleague Nancy Baker has done the work to integrate to PubMed services. So we have utilized the work she's been doing in-house for a number of years to build a web interface into what she's done. So in this case, we see PubMed Abstract Sifter as a sub-tab. For this particular chemical the chemical page I'm on, we use the CAS number and the name that shows up over here in the query. And then based on what you select from this particular pull down, hazard, estrogen, androgen, there's a whole list of queries that are pre-built. Nancy pushes the PubMed query based on mesh terms into this query box. And when you retrieve articles, it pulls back a list. So from over 20 million abstracts, it pulls back the title, the authors. This has also been fully rebuilt for this release. So you see the journals. If it's a review articles, you'll see a check mark here. You can select the articles of interest that you want using these check boxes, and then you can download it to your Excel file at your desktop, or you can send it to PubMed itself to grab the BibTeX list for integration into EndNote, for example. And you can also do the usual abstract sifting by starting to type in terms. So if you typed in estrogen here, it would highlight the number of times that term exists in the abstract. Then you would add your second term, your third term. There is a new capability here in terms of accessing the sifter for Excel.
The holiday is Saturday.
Sorry, you may want to put yourself on mute because we can hear you talking. You can also download the sifter for Excel that works at the desktop.
This is going over what? The chemistry dashboard?
Sorry, please
talk
over.
The leader has muted your line. To unmute your line, press #6.
Yeah, so just make sure, those of you that are on, that you've got your lines muted. But if you have a question now, you can type it in the chat box.
So the download sifter for Excel is a utility that integrates directly into Excel. Rather than go into detail on this is again is a talk of its own. I point you to the recent article we put in F1000 that explains how this was built and how to use the tool. This is definitely worth reading in terms of understanding how the abstract sifter came together. Under the literature tab, we also have subtabs that link to PPR-TV and IRIS. So if I click on IRIS, and there are data available, there's an IRIS report available for the chemical. It shows you that embedded web page directly inside the dashboard. The same is true for PPR-TV reports. We have continued to expand our list of external links. This has also been available since the very beginning, but we are adding more data sources in. And just as a quick summary of what these are, where necessary, we register the list of chemicals associated with these data sets if we can get access to them. We register them and use their identifiers to provide a mapping in the database. If that information is not available, then we use either a CAS-based query or an INSHI query or a name query to hit against those individual resources. So clearly, if we wanted to search Google Books, we're not going to map every chemical in every book that Google has, so what we do is push out a query based on CAS and name. If we are linking out to ATSDR, then we have built the mapping inside our database. Here's some examples. Clicking out to eChem portal takes you directly into the page about that chemical. The NIOSH safety cards, directly into the NIOSH safety card page. And for the comparative toxicogenomics database from Carolyn Mattingly at NC State, you dive directly in from the chemical into the page about that chemical. And then you navigate inside her application to find out where propylene glycol has been associated with diseases, gene interactions, genes, etc. So we're not trying to reproduce everything out there. We are trying to help you navigate to it. That's the very basic search level, is coming in as a single chemical, one CAS number, one name, one identifier. However, you may be interested in navigating through the dashboard based on other properties of interest. We have a lot of predicted properties. We've not yet surfaced the ability to search against all of those, but we have managed to get the mass formula searches in place to support the suspect screening and non-target analysis work going on in the mass spec team here inside the agency, as well as a number of partners across the world who are working closely with us to integrate data and use our search facilities. So here you can do a mass-based search, a formula-based search. If you want to use our facility to input a mass with an error and then generate all formulae and find immediately everything that's mapped to that, you can do that. There is a term here called MS-ready formulae. I will go into that in more detail. Andrew McCachran, who works in the group, has been working actively to help expand this functionality. He's sitting here in the room. He has a number of publications out that expand on how the mass spec support has been coming up under the dashboard, and a manuscript regarding MS-ready is presently going through internal review, and you'll be able to hear a lot about that as that's published. You can select either MS-ready formula or exact formula. Let's talk about the mass search first. You can input the mass with an error and perform a search based on Dalton error or parts per million. And we also have here the ability to choose from a set of specific adducts that you can search for. When you search by the mass with that particular mass and error, it goes through the dashboard and surfaces everything that has that mass. And that because you can search on both exact mass and so the searches are based on MS-ready masses. So what we are doing is we are excluding multi-component chemicals. What we mean by this is where the mass that you're searching on, a component of that multi-component system is in that particular multi-component chemical. This will become more clear as I show you the MS-ready type searching. This is a whole new redesign of the multi-results page. You can download and send directly to Excel, to an SD file, to a TSV file. You can sort now by all of the underlying metadata that we have available. And you can also, from a list like this, send to the batch search to continue extracting other information from the database. This MS-ready approach that we have, this underpins much of our analysis right now. And the MS-ready approach is regarding the fact that in mass spec, if there are substances of interest, multi-component substances, salts, chemicals with waters of hydration, you're not going to detect the entire substance that we might have registered in the database. For example, we may have diphenhydramine salicylate registered in the database. It has this unique identifier, DTXS ID. This is its mass, this is its formula. But this is for the combination of both components of the substance. If this was in the environment, you would detect it as the single component. This is what you would detect in the mass spectrometer. So this is the MS-ready form of the chemical. And what we're doing is we're using cheminformatics approaches to create these MS-ready forms of the chemicals, which we then relate to the substances that are contained within the dashboard. So as an example, diphenhydramine has at least 4 chemicals, diphenhydramine itself, the citrate, the hydrochloride, the salicylate, and likely a whole set of other substances. But this chemical in our dashboard would map back to all of the related substances. If you input this particular formula and do an exact formula search, you will only find 3 chemicals. However, for something like EDTA, ethylene diamine tetraacetic acid here, I can guarantee you that we have salt forms of EDTA inside the dashboard, and likely salts or where these particular moieties are components of multi-component chemicals. So while we only get 3 chemicals based on this formula, what we do with the MS-ready mapping is also bring up all chemicals of which these are components. So that same input formula actually brings up a total of 88 chemicals. And this is the advantage of the path we're taking, is that sometimes an individual chemical may not have a lot of metadata associated with it, but a substance of which that chemical is a component can have a significant amount of metadata available. That was a question that came up.
Yeah, we can address it at the end if you want.
Yeah, at the end's better. So this is a MS-ready formula search. This approach is being embraced certainly by the mass spec group right now, and we're working with a number of groups who are starting to use this and seeing distinct advantages. We've introduced a new navigation tool to help you understand how the batch search works. So you go through multiple steps. Each step is self-described. In this example, we are inputting CAS numbers. You now see informational icons, so you understand how each search is performed. CAS numbers, you would paste in a list of CAS numbers, and then it would immediately tell you to select the download data. So if I click on the download data, then I get to choose what I would like to include. Again, you see informational icons explaining what's available. When you check these boxes, this is the data that you will get served up. You have to choose the format you want, TSV, Excel, or SD file. Different formats are available for different types of downloads. So we have some examples here, Abstract Sifter and Metfrag, which are only in beta form. Those are Excel only at the moment. And again, these informational icons are trying to help you understand what is available under here. Just click and it will tell you. Not only have we put in the details of of what you can download in Excel format, but every list is also available. This is a growing list of functionality. It is changing with every release. So now you see PubChem data sources, number of PubMed articles, whether or not there's tox file data, etc., etc. So this grows with every release. And here's an example for that CAS number. You can tell it was found by CAS, what the mapped DTXS IDs are, what the names are. These are hyperlinks directly into the hazard data and into the ExpoCAS tables. So we're giving you a simple way to retain the file at your desktop and retain the search as it was performed at that point with links directly into the dashboard. We've been building families of chemicals based on people we interact with who want certain classes of chemicals brought together. So a simple question would be, what are all the PCBs? Can I find them? What are all the polyaromatic hydrocarbons? So you can now come to the dashboard and just start typing in these terms, and we've already pre-clustered them. So for PAHs, polyaromatic hydrocarbons, you'll see the entire list. You can scroll down, you can download it as an Excel file, etc., etc. So we can also build these lists, as I explained before, that are coming from different sources. When we register data from different sources, it's a list. When we build a list of chemicals to serve a particular purpose, for example, nobody supplied us with a list of algal toxins, but we have built a list called algal toxins. So they're not only what's passed to us to register, but also things that we feel will be of interest. When these are registered, they immediately map to all of the available data for properties, hazard, exposure, etc., etc. This is the list of lists of chemicals that we already have available. This is a growing list that we expand on with every release. We can also do it, if somebody provides us a list, we can push this out within a couple of days. One of the lists of interest that I spoke on last week at the ACS meeting was the EPA chemicals associated with hydraulic fracturing. If you click on the hyperlink, it will take you to that subset list. It's got 1,640 chemicals. You will be able to browse through them, send them to the batch search, send them to your desktop as an Excel file, etc. And this is what they would look like. All of these chemicals are now interactive in terms of linking into the chemical page. You would simply click on the name and it would take you to that chemical page in a new tab. With hydraulic fracturing chemicals, not all of them are structures. So these are structures that you're seeing. Many of them here have no structures, and the reason being is that they are complex chemicals. They are UVCB chemicals of a complex nature. We can't easily draw a chemical that represents it. Almond oil is an example, olive oil. They're chemicals, they have lots of properties we can measure, but we can't easily draw the structure for olive oil. These are a little more definitive than that, and we have started to do work to try and support this as best as we can. So each of these UVCBs is already registered inside the dashboard. Surfactants such as C11 to C14 linear alkyl sulfonates, we can take a stab at representing those, and we're already doing work like that. This is a CAS SciFinder representation of a particular bis-methylpropyl-phenol. We would have the CAS number is registered here, the name is registered here, and we actually give you members of the family that would map to that. That's one way that we do this. We're also working on these Marcouche representations. Marcouche is a term commonly associated with representations that you get into patents, and a Marcouche chemical would be enumerated, so expanded cheminformatically into an entire family of chemicals. So for C10 to C16 alkyl benzene sulfonic acids, this alkyl chain would be C10 to C16. It could be linear, it could be branched, it could be substituted anywhere on this ring. So this is an enormous explosion in chemicals. What we're doing is actually enumerating the chemicals, finding out what we already have registered, and mapping it back to the Marcouche representation. A simple example, which doesn't explode as much, is PCBs, where we have a Marcouche representation of polychlorinated biphenyl, and when you enumerate that, it gives you 209 chemicals, and you can see these are labeled in the related substances as Marcouche child. Going back to the test software again, as I've shown you, we have already pre-predicted all the values across the database. We've also worked closely with Todd Martin and working with a contractor. The individual algorithms that have been encoded into the desktop installable tool, which is a Java software which you can download for almost 10 years now. Download that from the website, run it locally. We have pulled out the individual prediction algorithms. We have reworked them in order to make them available as services on our side. So there are services available for these already that people can utilize. And then because we've made them available in this manner, we have now been able to layer on a structure drawing editor in the dashboard that allows you to draw a structure and hit these algorithms in real time. So under the dashboard now, if you look at the top next to lists, there is a predictions tab. If you click on predictions, it will open up a structure drawing editor. You can use this now to draw a chemical. You can copy and paste a structure you may have drawn in your desktop software. We have the capability already to drop a smile string in, and it automatically converts it and lays it out as a chemical here. That is available internally only at the moment. We intend to roll that out shortly. On the page, you can also do a search against the dashboard for any chemical of interest and then edit that chemical. So you might be interested in bisphenol A, which of course we have in the dashboard. So you'd search bisphenol A and it will load it into this editor. Then you may be interested in adding fluorines or halogenating it in specific positions. You would do that. If we don't have the chemical, you can't get the properties until you calculate. So here you would select your properties of interest and click calculate. In general, the predicted values are returned to you in a couple of seconds. There may be cases where each of the individual algorithms underpinning test failed for a particular molecule. I will show you an example of that shortly. But we will do our best to calculate with the 4 underpinning models. Here they are: nearest neighbor, group contribution, single model, hierarchical clustering. I need to get the link up to the test public peer-reviewed publication so you understand what each of those are. We also have a consensus model, which is the average that comes out from these individual predictions. Here we can see that oral rat LD50 was predicted only in 2 of the 4 and 2 failed. So not all models will suffice to predict for all chemicals, but in general you will see great success across the board. You will notice that we have phys-chem properties on one side and we have toxicological properties on this side. We have already made all of these phys-prop data that have been predicted available through the Chemical Properties tab. We do have these data predicted. We do not yet have them surfaced through the dashboard. We intend to do that for the August release. We will be making a movie shortly to show how to use the structure drawing editor so that you can follow the movie to draw your own chemical structures and calculate. Internally, we also have these hyperlinks here will link to a detailed calculation report that is not yet available on the public version. We hope to have that released within the month. So let's move to work in progress. I've shown you what we've been working on, not in exhaustive detail. There's a whole lot of other things I could show you. We don't have the time, but I want to show you some of the more exciting things that we're working on at present. So this is test predictions. Toxicity estimation software tool. We intend to put a tab here that allows you access to opera predictions. Those are the algorithms that I mentioned earlier, developed by our colleague Kamal Mansouri, who was here as a postdoc, and he's now moved on, but all algorithms are still maintained in GitHub. We still collaborate to make sure we get the latest and greatest. So we want to make those predictions real time also. The other aspect of this is you can only do 1 chemical at a time. Clearly there would be interest in 1,000 chemicals at a time. So we are considering how to allow you to submit an SD file, 1,000 smile strings, an Excel spreadsheet, and predict all of these properties, opera and test, in batch for as many chemicals as you would like to submit. Work in progress, not complete. We're also working on structure-substructure and similarity search. We already allow you to do searches based on name, CAS number identifiers. You can search on an INCI key, which if you like is an explicit structural representation encoded in an INCI. And we already do a similarity search in the dashboard, but that is an automated mapping to similar chemicals. We do not yet provide you with structure-substructure. However, we've already integrated a structure editor. So this is a multi-step process. We start with the editor. You will be able next to draw the chemical structure of interest and do an exact search. You will be able to do a substructure search. You'll be able to do a similarity search. You'll be able to have a substructure and find that substructure contained in all chemicals with specific formulae or weights. And as an example, if I use this particular substructure and search across the entire dashboard, it shows 2,540 chemicals rank ordered based on similarity, and you can see that we have color highlighting of the substructure. This is a prototype. It's already running internally. We are working towards an August release. We're not sure we're going to make it, but we are already testing this internally. We're also working to merge in other dashboard capabilities that were developed earlier in NCCT's history. So I'm sure you're aware of the ToxCast dashboard and the EDSP21 dashboard. We also have ACTA and CPCAT. CPCAT has transformed into the CPDAT database that we have inside the dashboard. We already have aspects of the ToxCast showing up, but not all. We're presently working on integrating bioassay curves, and this is coming up in the next few months. Pointing you to the downloadable data, if you're interested in what we supply as downloadable data, these files will all be updated over the next few weeks. The last time we put these online was in late 2016. We're already in early 2018. We have a number of these files already generated since the last release. We just need to find time to post them, and they will all be updated for you to use. So in the past 40 minutes, what I've tried to do is explain to you what we've been up to with over the past couple of years to get to where we are with the dashboard and provide you an update with the latest release. So version 2.6, we used to release every 90 days. Every release consumes about 30 days of work for us. The process involves us going through internal staging of what we've developed. Then we push to production staging and test out in the outside world. So outside in the DMZ, we then push to, have to go through an application scan, then we go to production. That entire process consumes about 30 days in general. We've decided, because we've reached a certain level of maturity, that we will go to a 6-month release cycle. It doesn't mean that we won't fix bugs during that 6-month period. We won't roll out necessarily new data, but major functionality will only release every 6 months at this point. The latest release has expanded on the database by a few thousand chemicals. We've added a whole new set of lists of chemicals of interest inside the agency. We've been integrating new sources of data, both functionally at the tab and sub-tab level, as well as through the external links. That list of interest grows as we get involved with certain projects, and the intention is to make sure that every publication that comes out from us, as well as providing it to the publishers as supplementary info, will also make it available in what we would think of as more consumable forms. Excel file, SD file, hyperlinked fully into the dashboard so you can access all of the data. I've shown you that the real-time prediction models rollout has begun. We've started this solely with the test prediction models. We are working on Opera. We also have a number of other models that we've been building internally over the years, and we will roll these out incrementally once we've proven them. We intend to roll them out as real-time prediction models for single chemicals. We intend to make it available for batch chemical, and ideally we will also have web services available for anyone in the world to hit those services with smile strings and pull down the prediction results in JSON format as an example. I've also tried to show you that we've got an exciting array of additional searches coming: structure, substructure, similarity, combined formula, mass with substructure. This is all going to continually support the efforts we have around suspect screening and non-targeted analysis and structure elucidation. This is not a joke. I know it says April the 1st. It is earlier by a few days, but April 1st, 2016 is the day that we actually went live with the first beta release of the dashboard. April 1st of this year will be the second birthday. We've kept up the pace of development of integrating new capabilities, and we hope that you'll help celebrate the second birthday by using the dashboard, giving us feedback. There is a submit comments button there, and just letting us know how we can continue to develop it and support it, to support the community. Acknowledgements go to an entire team of people that are in the background that you're unlikely to ever meet or hear from. They're busy at work building on a daily basis, supporting. We have an incredibly skilled development team. All of the scientists inside NCCT are either providing data or providing feedback and supporting the development of the dashboard. We're very fortunate to work with colleagues in NERL and the mass spec team who give us an awful lot of feedback and stress testing of our developments. Kamal Mansouri, who was here at the EPA and is now moved on to other pastures, continues to maintain the opera models, and as I mentioned, he is working on other models for us to add in, including a pKa predictor. And also for Todd Martin, who worked with us on the test predictions and to make that work in time for release. This is my contact information. I can be contacted by email if you have any questions. Please note my name does not have an H in it. That's a gentleman in Las Vegas who gets paid for my credit cards. But I'll answer the questions for the dashboard and available for any questions. I'm going to hand back to Cameron.
Yeah. I'm going to unmute our lines so that folks can ask any questions they might have that way.
The leader has unmuted your
we
line.
have one through the chat function. All right, so is the version of test referred to here, 4.2.1, downloadable, and what year does it correspond? Also, is the bioconcentration factor predictor now using the Arno-Gobos feature algorithm that accounts for some biotransformation in fish, in addition to the log KOW-based regression? For the record, I have test version 4.2 of 2012.
So thanks for the question, Sergio. The version of test that we use is the latest that was made available by Todd Martin, which I believe will be 4.2.1. I am going to take your question and check with Todd directly which version of the bioconcentration factor predictor he's using there and get back to you. If you can put your email into the chat box, I'll make sure that I connect us all up. I can't answer that question at this point, I'm afraid.
All right, well, any other questions on the line, in the room, or you're welcome to type them in the chat box as well. All righty, well, hearing none, I'll go ahead and let everybody go. And I want to thank Tony so much for presenting today and thank all of you for joining us. Hopefully we will meet up with all of you again in April. Until then, have a good month.
The leader has disconnected. The conference will be terminated in 5 minutes.